So let's quickly talk about vapor-liquid equilibrium. We're not going to go in detail about equilibrium because we got a whole unit about equilibrium. But I want to definitely dip the toes in the water. So we about to talk about it. First, before we even go any further, right, let's talk about what exactly is equilibrium. Two opposite processes reaching the same rate. Okay, so they reach the same rate. And there isn't going to be any losing or gaining of material. But the rates are the same. And once we have the same rates for both processes, we have reached dynamic equilibrium. This does not mean that we have equal amounts of vapor and liquid. Okay, that's not equilibrium. If I got 20 milliliters of gas in my container and 20 milliliters of liquid in my container, we are not at equilibrium. That's not meaning the same thing. Okay, this means, right, that we're changing by those equal amounts. Okay, so vapor pressure, just to remind everybody again, this is the pressure of vapor over a liquid at equilibrium. Okay, vapor over liquid at equilibrium. So let's talk about this. Let's talk about this even more. So bam, we got a container, this Erlenmeyer flask. Okay, I got some liquid matter in this container. What are we going to start seeing? Eventually, that liquid will start to evaporate. Right now, my liquid in my Erlenmeyer is evaporating. Okay, and we can see, right, starting to get that energy. All right, it's going up. Bam. Bang, bang. We get, as we mentioned before, tiny bits of those gas molecules escaping, right, to form these gas molecules. So this is what we're seeing here, little bits of them escaping. Bam, bang, bam, bam. And during this process, okay, we're going to reach a point in time where our rate of evaporation, so going from liquid to gas, right, that rate will be the exact same as our rate of condensation. So condensation, right, we can see condensation kind of starting here, right, just a little bit. And remind you, condensation is when our gas molecules go from gas to liquid. So we can see, right, in point C, at this point, this is where we reach our equilibrium. So basically, this is letting me know that as many liquid molecules that are converting to gas, there's as many gas molecules converting to liquid. And this is what I mean by the rate. This is the same rate. All right. So say I'm converting 5 liquid molecules to gas, right? But at that same time, I got 5 gas molecules converting to liquid. That's the same rate, right? It's the same amount happening at the same time. Okay. And when it's at the same rate, we reach our equilibrium. Okay. That's where our rates are the same. So we can see this with this graph here, right? Over time, our rate of evaporation, right, reaches its limit. Bam. This is where it's going to start reaching this limit. It starts to plateau. This is our rate, and then this is our time. So once it reaches that rate, it plateaus. Bam. Look at our rate of condensation. Now, right now that the rate of evaporation has plateaued, now, as what I mentioned before, those gas molecules, they're going to start hitting each other. Bang, bang. Okay, bang, bang. And as they hit each other, what are they going to start doing? Those collisions, okay, they're going to start forming together to form those liquids, which we see going on here, right? We got those gas hitting each other. Now, bam, they're forming those liquids. So once this condensation starts to happen, right, this happens once it reaches that rate of evaporation, it plateaus, what do we start to notice? The rate of condensation is going to start to increase. And as it's increasing, rate of evaporation still plateaus, we're going to see now that the rates are the same. And at this moment in time, our rates are officially the same and we reach dynamic equilibrium. Okay, the rates are the same right now. The rate of evaporation is the same as the rate of condensation. And this is how we know we got equilibrium playing a role. Okay, so like I said, quick hit right there. We got a whole unit dedicated to that. Okay, but definitely you want to understand that at this process with equilibrium, our rates are the same. Not the amount of stuff we have, our rates.